Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Uh, I continue with this basics of highway geometry design. This is part 2, and we'll try to discuss the horizontal alignment in this part. Uh, as uh, but horizontal and obviously the topographic map. My dear students, whether you are doing it in the software or do it manually, I must emphasize that you must know how to read this topographic map before loading it on the civil 3D or before embark on on the mission of geometry design of highway. Mainly for a topographic map, will try to have gather two values, two different uh, aspect. One is whether the topographic map contains the information of a developed area or not developed area. Because if it contains the information about developed area, obviously we will be talking about designing or setting standards for uh, for our highways, urban highways. And for rural highways, we'll be setting standards accordingly. So it's very important. How to identify? In a couple of seconds, you will know. The other thing, the that is also related is about your terrain condition. Uh, to be very specific, there are three types of terrain. One is the level terrain, in which the ground is somewhat more plain uh, than it's an ideal scenario. Then there is a mountainous terrain, in which there are steep slopes, steep mountains, high-rise mountains, and then there are valleys. And there is a rolling terrain. The rolling terrain is actually a level terrain, but undulation of the the ground every now and then. And now, if I I try to explain this level rolling and mountainous terrain, and I have read this definition from the capacity analysis manual, in which they define that if you have a car and a truck and both are asked to drive on a roadway, and if they can go with their maximum speed, it's a level terrain. In the rolling terrain, what happens is that car is not going to change the gears while the vehicle, the heavy vehicle, it has to change the gear. That is a rolling terrain. And for the mountainous terrain, both have to change the gear, but the performance of heavy vehicle will be slowed down, and it may not be working, its engine may not be working to get that speed because of that terrain condition. And this is the definitions. And when the hills are not as massive mountains, hills are elevated areas with slopes and peaks. Now let's go to the topographic map. This is a typical topographic map, and on dot map we need to determine two things. One is the type of terrain. As you can see, and there is a general guidance, if your contour intervals are up to 5 meter, then it is a level or rolling terrain. And if it is around 30 meter or 40 meter, then it is a mountainous terrain. And again, for gravel and rolling, you need to understand the every now and then ups and downs on the ground. Obviously, that will not be very significant, but still they will be. A level may not have a very sharp mere rise and fall at frequent intervals. About the Kalko answer, whether the map shown here is an urban area map or a rural area map. From this topographic map, there is no building you can see, there is no developed features you can see. So you can easily say this is a rural area. But mind it, sometimes you have an AutoCAD drawing and some of the layers may be off. So what I am saying, when you are looking at this topographic map, please check to see that all the development benchmarks, the layers that have got development marks like buildings, mosques, roads, they have a that layer is not switched off, because sometimes, because all these features are developed, are being drawn on different layers. So if you think, and if you think that okay, there is no land, there is no development land, but actually they may be, because the AutoCAD drawing that you may have been provided may have this switched off. So what I'm saying is toggle all the switch on and then see your topographic map. So these are the two things that will help you determine whether you are in terrain type and as well as the, uh, the area, rural or urban. From this map, we can easily say it has an interval of 5 meters. And two consecutive contour has a 5 meter interval, so that's a level terrain. And obviously, there are no landmark we can see, there is no buildings we can see on this map, so it's the rural area. So we have been given a map that has got level terrain as well as it is a rural area. So we have to connect point A to B in this style, and we have to set standards. Now, once we know that thing, let's move on to marking or alignment. Uh, you know, some of May you have been studying this course first time. You have to be sure that whatever plan, there is always a plan map, plan sheet, there's a profile sheet, and there's a cross-section sheet. The topographic map that is given is your plan sheet, and whatever lines you mark is of horizontal alignment, or is of horizontal alignment. So we'll have what we do. If we can go back to my topographic map, all the red lines is marking horizontal alignment. So what we have done is actually, this is my center line, or maybe this diagram will explain this better, right? Maybe this diagram, this is the horizontal alignment. It's associated whenever there is a change in direction, we introduce a curve, and this is the offset. You can say it may be your right of way, 100 meters, so it's 50 meters on each side. So let's go back to that diagram once again, in which I have shown the horizontal alignment. So this is my horizontal. So whenever there is a change in direction, I draw this curve. So from this alignment, I have to have two curves, one here and the other is that one. And now, how much this radius of the curve, it will have to be determined by setting our design control. So our design speed is 120 kilometers per hour. of 75 miles per hour, because since it's a rural area and the speed limit is 7 this. Along with that, we have to have a super elevation that is 4 to 6% and 6 to 8%. And once you know that, you have to know, you can calculate the radius from the green book. And the radius from the green book is like from table 3.7, you have a 120 kilometers per hour speed, 8% super elevation. So consequently, your radius will be 677 meters. So this is again from the green book we get this value. Because the radius is dependent, radius is proportional to the square of the speed and inversely proportional to the super elevation. So once we have fixed super elevation, as per the guidelines, we know the design speed, we can always find the minimum radius. So that's how we calculate radius from the green book. And then once you do this thing, once the radius is known, you have to know the delta, and how you will know this delta is, again, if you extend this line, you will get this delta for this curve. And if you extend that line, this delta is, again, it's around 67 degree. If you look at this word here, it may not be very big, so it's 67. So what is the deflection angle? We'll extend our alignment, and then whenever this change of alignment, this is my change of alignment. So this is my degree of curve. So we know delta and we know R. This point is pi of the curve, and obviously there are two pi because we have two. So when we have three parameters known, we can always find the other parameters like degree of curve, tangent length, external ordinate, middle ordinates, and we will find ultimately all the parameters that are required to set up of the curve. Important check is one of the guidelines that whenever you find these two curves must be separated by 100 meters. What I am trying to say, and you must listen carefully, that the PT of this curve and the PC of the next curve should be separated by at least 100 meters. So this is always the check when you draw horizontal alignment, that though no curve, all the curves, all the consecutive curves should be separated, should have been separated by 100 meter distance, and that's very important. So one of the check is this. Otherwise, this curve will overlap, and we will see an error while you will be doing this in your digitization of geometric works. So let's go back. So once you know this horizontal alignment, you will calculate all those things. There is one more thing that is called horizontal sight line offset distance. And this you calculate from this table, this on the green book. You know your radius, you know speed, and you find this HS. So this is the distance, how much vehicle your alignment should be away from the center line of any building obstruction, so that you have an adequate sight distance. So this is HSO. Another thing you need to do is to provide super elevation. For that, you have to refer to my other video that is especially provided for this, and that's why I have actually have get this values, but again, the detailed explanation you will find in one of the lectures on super elevation. Actually, there are two lectures on that, or two videos on that. So all my viewers are requested to go there for have a detailed explanation. I could not avoid it here because uh, it's thing that you need to know or you have to provide while providing the alignment, horizontal alignment. And obviously how this spiral curve, all these has been explained. This is the table and this is the curve. This is the profile you have to have uh, for your road alignment. And this is for the center line of the road alignment. And and these are the provision of superannuation. Now, another thing you need while providing horizontal curve is the curve at the curve width is sometimes different from the tangent width because the design vehicle occupies a greater width since we have a two-wheelers or what we call uh, front wheel drive. So our front wheel can turn, but our rear wheel cannot turn. So that's our vehicles get offset, and always there is a driver experiencing the vehicles in the center of the lane. This is a problem. This is flexible, it can move, and this is rigid. So this will have another path, this will have another path. Ultimately, you will see the position of the vehicle offsetting. So if offsetting from your lane, or maybe if you do not provide an extra weight, it is possible that this wheel will be on the not on the pavement and may the vehicle may damage, may overturn because of this thing. In order to know the widening, also we need to know what design vehicle we have. And this is for WV67, in which wheelbase are 67 fits apart. And for our curve, 700 meter nearly and 100 kilometers per hour. Remember, we have, when we say 120 kilometers per hour, we talk about the speed of the low or passenger cars. But the vehicles, heavy transport vehicles, cannot be more than 100 kilometers per hour. That's why this table is showing you this value. And then there are three ways, there are three distinct areas in this table. One are three column, 3.6 meter lanes, 3.3 meter lanes, and 3 meter lanes. And each of these values has got three distinct areas. One is the gray area, the other is a white area, and the third is the black area. Now, for our case, we see that there is the value is 0.4 and it lies 0.4 meter. So it lies on the gray area, which would mean that widening is required, but if you have a leverage to provide, you may or may not provide, because some providing a widening is not an easy job, and that's why if you don't provide, it may not have a significant effect on the movement of the vehicle. So this is where the gray area is. Now, when it comes, if for instance, if I would have a radius of 300 meter, then I would have required 1 meter. Now we have to provide 1 meter, means your width along the curve should be 8 meters, 7.2 plus 1 meter, 8.2 meter. But what about this? It means the 200 meter radius, and for 100 kilometers, there is no winding. Actually, it does not say. It says for 200 meter radius, the speed of 90 and 100 is impossible. So this 200 meter is actually not adequate radius. You must have a bigger radius. You have to provide a bigger radius. So this is how you can always have this. And now, since obviously you cannot teach everything, this is for WB67 vehicles. But there are in a histo table, in a histo book, the green book, the values for other vehicles are also given. So what if you have got 0.4, you have to subtract or add other values for your vehicle. So this is I leave to you to do it yourself. So that's it. Uh, my second part. I hope I was able to communicate my knowledge to you. Allah Hafiz and take care.